So we have collected the different questions that have been shared during the session, and we will now go through them. We had 3 presentations. I want to thank the presenters who actually linked well together, though maybe in a strange order, in the sense that Pieter presented really the back end of how data can be collected and linked, with Wouter showing how that can be then used in application towards with digital twins, trying to understand it more. And then on the other hand, the presentation also from Benjamin showing actually how you can understand those values and then which sensors to use and challenges more related to the measurement itself. We have collected the different questions and make a few selections. So I will go through them first from one speaker to the other, and starting with the question we have collected for Wouter. So Wouter, we had a few questions. I will start maybe, I will keep the most simple and easiest one at the end about is that open or not, what you have shown, is it available? But first, there was a question about data calibration. When you have building automation systems and you use it for HVAC control, that data needs to be calibrated. The person wanted to know what is the best procedure for this, and from your perspective of the digital twin, do you see some advantages or disadvantages of using the digital twin to do the calibration? Because you mentioned comparing the BIM with the measurement data, but you still have to calibrate the measurement data. So how do you fit in the calibration within that process?
Yeah, I think some of the model, if you have if you have the digital twin, which incorporates also the model, the calibration is a how to call it, a procedure which is separate of the model part. So we do it by hand. You can use like data and calibrate it using the dynamics of the system, like the cooling down period of the building to calibrate it, or you can use, for instance, every yearly use, or put energy use for combined with outside temperature to calibrate data, and it can be steps. But what we also do, and especially have some experience with in the chemical industry part, where we use separate software, where we can have a special user interface, where we select the training data which you want to reuse, so which period you want to use for the training data, and we have automatic procedures for calibrating the model. So the model and the calibration is separate processes, and yeah, ideally you want to automate do the process, the calibration process automatically, but the selection of the time, the training data, that is a part that you always have to do manual, also for quality control. And to answer the second questions, are there advantages or disadvantages of digital twin approach? I think one of the main topics, if you want to do use data analysis, it has to be fast. So if you have high quality data and you have enough high quality data, it can be quite attractive to use like black box model. You don't need a good BIM file or a good physics model. But yeah, in many cases you don't have those high quality data, and then it is an advantage to use more like hybrid models as we presented in the Siren TNO model. I don't know if that answers your questions.
Well, I can't answer, of course, for the person who has asked the question, but at least it gives a hint towards it. We are short of time, so I don't think we can go through all the questions, but maybe the second, because it's related, but in a certain brief way. So you presented how you can use those combination of digital twin actually to compare what is designed with operated values. The person asked, how is it done in practice? What you've shown is research work. So maybe translating the question, in practice, do you see that, like, is it future work? Do you see it already feasible on the short term, or do you think only, for example, for complex cases and not, for example, for small residential buildings? How do you see the complete implementation of
Yeah, I think so. It's also presented by the second presenter. It's quite also depending on what you want to research for. You have the sensor data and you have the data from the building management system. But if you want to have, like for instance, COP value of the heat pump or the seasonal performance, or you want to look at the energy performance, and those models can help assessing the data. For instance, if you want to correct them for the heating season or the cooling season, sorry, for the climate season. So first you train the model and then you calculate, for instance, for how to call it, a reference year to look if the performance is met. And we've done that in the past. And we will also do that with the 2 Horizon projects we mentioned, also the AI program for projects we already we're going to monitor and already monitor, but we also did it in the past. Use the how to call it, the current data to train the model, and then use a reference year to look if the energy use is as expected. And especially also with prediction, you train your model based on your data, and you can do a prediction. It can be like either short term, or it can be for longer periods. We are also working for some projects where we will do model predictive control, and then the production horizon will be 6 hours to up to 3 days. And we use this prediction to balance energy needs on a district level. But we always will use, for instance, these models to check if indoor air quality criteria are met in a housing project where we already collected data now. And for another model we use is also for IAQ sensors. We had like 100 IAQ sensors, and we use the model also to get how to call it, calculation of the exposure, and also use these models to detect what came from which particle matters came from outside and which particle matters come from inside, so we can have an idea about the sources. So and the question, complex and large models versus smaller models and family houses. Also, if you look into, we have one of the predictions we did on the office building with 2,000 workplaces with 600 sensors. You can have a relatively simple model there. So we use only like one zone model. I saw also a presentation of the DTU, and they also have very complex model, and they used a gray box model with only one zone. And for dwellings, the 2 dwelling projects we are now doing, we have like multi-zone model for a dwelling. So I think the complexity of the model doesn't depend on the building itself, but it also depends on the quality of data you get. And that is more like, how do you call it, a factor than the building itself. And also what you want to predict, if you want to predict single indoor air quality in a single room, or you want to have like the ventilation flow for the entire building.
So it seems the answer is very in line also with what Benjamin said. Is really know what your goal is, and based on your goal, define your methods, both your sensors, your data approach, and then
and also what I also try to analyze is that how much information is in the data, because the amount of information in the data also limits itself in the detailness of your analysis. It doesn't make sense to have a very detailed analysis with a multi-zone model if you only have very limited information. And it is not the amount that you can have a measurement every second, but it is also where you measure and how the quality of the sensor is.
Yep, thank you. And that leads actually directly to a few things that Benjamin showed, and 1 or 2 of the questions that were asked also towards Benjamin. As you say, you can have all the sensors, you have to choose, they're not always well located. And Benjamin, you have shown the potential of having an approach of fixed sensors, but also the potential of having an approach of personal sensors. And an interesting question that was asked was, do the fixed sensor always measure the correct data? And what is the gap between the place of the sensor within the building compared to where the person is. So you could also translate that to in your case, how do you deal with that match or actually mismatch between the two? Because you said we can have very accurate location sensors and less accurate personal sensor, but they're not at the same spot. So how do you deal with that?
Well, we deal with what we have, and that is something I learned since I've been doing measurements in the field or in buildings and not in the lab where we can control everything, is we have to do with the measurement that we have in directly when we put sensors directly in buildings. So for fixed sensors, they will not tell us, they will measure the pollution levels and the environmental parameters and everything that the sensors are designed for. They will be measured. That does not tell me if the people are close to the sensor, or so if the concentration that is measured really represents the exposure. So that are two different questions. And actually, this is completely in some way it is disconnected, the measurement by the sensor, and is there somebody here, and does that represent the exposure? But then on the other way, and that is one of my main research interests, is there is a link, everybody knows that, about between pollution and people and health. But the link is not that pollution or chemicals will make health problems for people, is that also people, by their presence, by their activities, will pollute and will emit some pollutants. So actually, as there is a chemical signature from activities, there is a chemical signature of presence of people. Okay, so which means the mere presence is an activity, and with that, we could see, or we could try to derive, is there somebody close to the sensor? And close is voluntarily not precise, because it depends on the size of the room, it depends on the ventilation of the room. So I would not know what is close so far. Is it 1 meter? Is it 2 meters? Is it 10 centimeters? I don't know yet. Okay, but okay, the sensors measure what they are, and if there is somebody close to the sensors, then it corresponds to its exposure.
It brings actually a little bit also to a next question, because you mentioned that it is a way to notice an activity, the presence of people, the pattern of a person, just the fact that the person is present. Of course, you need to train that data to be able to understand the match between the signal and the activity. And an interesting question was actually, how accurate is occupant self-reporting behavior of events, for example, such as cooking? Because in a lab, you can do experiments and try to match a signal. Of course, the future with big data and IoT is to be able to learn from the huge amount of data and to be able to discern more and more patterns and more activities. But of course, you need to train that. And one of the ways is asking people to report what they are doing and when. Do you have a sense of how accurate that is and how that can influence your findings?
Okay, let's say that out of the, if I'm right, 10 weeks of really intensive measurements with several volunteers, probably they missed each about 1 or 2 events per day. And that was during lockdown, so they were locked in their houses and doing lots of activities and lots of cooking, a bit less of cleaning. But so they missed some events. And this is really interesting in some way, because I do not know yet if they missed some events because they just, well, forgot to report it, or if those events correspond to some activity that people were not aware could produce some pollution episode. So, of course, people have a bias about what they were supposed to mark down for us, okay, is what they think pollution is and what they think pollution comes from. And so maybe it's like, okay, cooking, everybody knows that cooking pollutes. Well, not everybody knows that what kind of dish you are preparing. Frying is much more polluting than boiling water or boiling pasta and everything, but really much more polluting. So factor 100 in terms of particles. So it's not even the energy that you use. It's just the kind of dish that you're frying. So that's one thing. But if I say that vacuuming produces pollution particles, really fine particles that goes through the filters, okay, nobody knows that. Well, we do that. So, or we do in the indoor air chemistry community, we know. So it's either a bias of not knowing what to write, okay, either some just forgetting of writing things, but basically there were really few events that were missed by the people, at least the start of the event. Because one of the main points that we've seen is that, okay, they know when they start polluting, but they have absolutely no idea when it will stop and how long it will take to decrease and to revert back to normal. So they will say, okay, I've been cooking for 5 minutes between 12:03 and 12:08, and some people were precise that way. But of course, the pollution plume was still in the room for hours.
Yeah. So I think there's a lot of more research to do to filter it out, so that the reporting bias is a big issue, especially for people hoping to measure it and try to understand. It's actually about linking activities with sensor data, and linking data is more what Pieter was talking about. Pieter, we had actually relatively few questions, I have to admit, regarding your presentation. I think that maybe some people were a little bit impressed by what you've shown. But I think that two of them might help frame the picture. Is one, if you could give a concrete example of application where that linking of geometry and the sensor data is that crucial. But also, where do you see the big challenges with linking the data? You've shown a few like privacy and those, but you have some solutions. But where, according to you, is really the fundamental challenge that we are facing with linking that data?
Yes, I assume there's not that many questions also because it were a lot of slides and a little bit of time also going in a topic slightly different from the others. Yeah, I can. Example of applications that need links between geometry and sensor data. I think you can already see this in the application that Wouter showed in the beginning, which had 3D geometry in the browser, including sensor data. So what I think we want to have there is at least to be able to know where the sensors are and how the data is linked to which sensor, to know where they are in 3D geometrical space, because that also matters. So it's to some extent also to enable better understanding by the user, which I think is important. What else? Yeah, and what are the main challenges? Yeah, and it's also not only about geometry, but it's also about using that BIM data. So at the moment, these models are being built also for those existing buildings. So it would be useful if you can rely to some extent on that incoming data. I'm not saying that we should use all of it, but we should be able to use some of it, and that is, I think, important also for those BIM models. Which were also in the previous presentations. So I think that's where I would like to make the link. So it's basically providing data. That's for the first question, I think. And then for the second question, what are the main challenges while linking the data through APIs? Yeah, it's a different kind of linking. You basically need to handle within your software where all your data is stored. So that's a whole other level that I think is the most difficult part. For example, if you use one graph, it's stored in a Stardock database or in a GraphDB database. You have a triple and it says sensor is part of the node. Then you need to get your sensor data, which is in a time series database. So you basically need to find out your sensor in that other database. So you need that identifier match. And in theory, it's all very simple. It's basically programming and making sure you have the same IDs, but that is often more difficult than it sounds. So that part is that's the main challenge. And how do you maintain also that link over time? That's one of the challenges.
Thank you. I see that we are approximately nearing the end of the time slot that we have for this webinar. So we had a very few brief questions actually related across all presentations, but they are actually most of them easy to answer or actually to postpone the answer. Like, for example, is the Annex going to deal with the cost benefit and optimization of different tools? So because that is not that cheap to do those things, I can already briefly answer that within the Annex, we will of course look at different, not only state of the art and research, but actually really case applications from also companies. And there, of course, the business case is one part of the things we will look at. It's something else than say we will do real financial analysis. But it's something, of course, if you have interest or recommendation, please also contact us now during the preparation phase or afterwards. But of course, the application is crucial, and that's why also we need the companies, and we will look at that application cases. So I think that is also one of the big challenges. There was maybe one small question. If somebody has like something that he thinks really for this Annex, it's like, what will be the greatest challenge for collaboration between a different organization? We've seen totally different fields of research being presented today. And I don't know if one of the three speakers, like listening to one another's presentation, thinks, okay, here we have an issue that the other might not have noticed, or that might be a challenge in the collaboration phase. I don't know if any of you three think that we might have an issue here. To wrap up the webinar.
Yeah, maybe I see Wouter is eager to answer, so I'm sure I will give you the mic, but I think we will face that now also in that project, because we are going to collaborate across organizations. And what I think will be the biggest challenge there is that you have different gaps, I mean, areas of expertise, which you need to bring together and not transform it all in one or the other. I think that's one of a bigger challenge besides pure practical implementations as well.
I think also something I want to work together with Pieter also in the brainstorm building project is the question which was asked to Pieter from how can we link the BIM data with the IoT data. So maybe also especially for the geometry part, if you have like Project Haystack, for instance, as a data protocol, can we link that to IFC or GBXML? And also for the energy modeling, I think that is quite interesting if we can make that link. I hope for some collaboration in the coming years on that.
And Benjamin, is there something additional you think that, oh, this we might
Yes,
have
I think that there is one thing that we should consider. And okay, we all put sensors everywhere, lots of sensors, but do we really need all the sensors? And so the question is for all of us, actually, starting with me, is what is the minimal amount of sensors and measuring what that we need to install? So it's probably not worth putting sensors everywhere. It's just we have to find the right sensors and the right measurement. And so we really need to consider not putting sensors everywhere, but measuring the right thing at the right place at the right moment. All of us.
Yeah. I saw also in the Q&A something about cost. I think it's article to find like a minimum sensor position also for like dwelling in offices, and also to get a good business case, because we can measure everything and we can analyze everything, but I think a minimum sensor configuration is quite interesting also in how to create a maximum value.
I think that brings together a word that occurred, I think, in almost all the three presentations, maybe in a different phrasing, but a tsunami of data. And of course, you can try to handle that tsunami of data, or you can also try to just reduce that tsunami by, first of all, thinking whether or not it's needed, making our own lives a little bit easier before we try to solve it. On this, I want to thank all three of you, really, Wouter, Pieter, Benjamin, for the presentations. Also, especially, I want to thank all the participants for having joined the webinar, asked the questions, and participated. I especially also want to thank Maria and Valerie for setting this up, for helping me collect all the questions and preparing for the Q&A. So I will now wrap up by referring again to the total workshop. So within a few days, you will be able to see the recordings of today, but you also can already see the recordings of the previous two webinars. And next week, there is a next webinar on big data and IAQ, which will be hosted in the same way as today, but with speakers from industry. Important is, of course, to ask you all when we will wrap up this meeting to fill in the last survey. It really only takes a minute. It's very important for us all to get better insight on how can we make the future webinars better than this one, and we always want to do things better, of course. Thank you very much, and hoping to see you all next week.